Uh, Good afternoon, everyone. Thank you for giving me the opportunity to present my paper. Myself, Mohammad Jafaria. I am a PhD student from NC State University. Um, this work was a collaborative work between NC State and the New York University. Let us first see the motivation of this work. Today, we see households are equipped with numerous IoT devices, which makes our daily life more convenient. But the convenience comes at a cost, and the biggest cost here is the user's privacy. We see smart devices often collect personal data and potentially can share to the third parties like advertisers or trackers. Here I am showing some news articles that shows huge concern on user data privacy being potentially jeopardized by smart home devices. In this paper, our objective is to analyze a real-world IoT traffic for characterization and finding the privacy implications. This specific type of work is not entirely new, but what is new in our work is analyzing the organic data. Based on our data and our analysis, we try to answer 4 research questions. In the first research question, we wanted to know the distribution of different endpoints for different smart devices. This type of information will help us to identify devices that pose higher risks to user privacy. In the second research question, we wanted to know the impact of user locations to the endpoint distributions. In third research question, we investigated how frequently the data cross the geographical borders. Such analysis will help us to identify potential privacy violations. And in the fourth research question, we look how IoT ecosystem evolved over the years. For the time constant today, I will focus on the first 3. For the dataset, we collaborated with the IoT Inspector team from New York University. The IoT Inspector is a free and open source tool that anyone on the internet can install on their computer to monitor their home network. This tool collects the device metadata and aggregated flow level information and sends to a remote server. We collected those data for more than 65,000 of devices, 6,000 users, and from all around the world, and for 3 years time duration. This is our overall workflow. We first identified the device from the device metadata and categorized them into some groups. The device identification means finding the device name and the vendor names. And then we categorize the remote endpoints based on the relationship with device vendors. And finally, we analyze our data to answer the research questions. So, the device identification process was a crucial challenge for our dataset. The inspector collects 5 meta information. Here I am listing in the left. We used a combination of this metadata to manually infer the device identity. And using this approach, we identified a subset of devices. To make our device identification process more scalable, we utilized a large language model with 3 meta information, and we use the API for GPT 3.5 Da Vinci based model with no fine tuning. To infer the company name or the device type, we designed prompts with a single metadata, and therefore we have 3 different prompts with 3 different metadata. If any 2 responses were consistent, we identified the record as the device identity. This is the outcome for our device identification process. Among 65,000 IoT devices, we could identify more than 25,000 devices. In the red box, as you see, there were some devices which was identified one approach but not by the other. And on the right, I am showing the categories that we identified devices. We categorize them into 8 categories. In our second step of the workflow, we categorize the remote endpoints. Based on the relationship with the device vendor, we classified any endpoint into 3 groups: first, support, or the third party. First parties are basically the manufacturer or the related company which are responsible to fulfill the device functionality, such as AWS for Echo device. The support parties are the cloud services for IoT, such as HomeKit for Samsung devices, and rest of them are third parties, including any advertiser or trackers. The idea for first party detection was very simple. Given a device and a remote endpoints, we first fetch the vendor information and the endpoint information. Then we match the two sets of information. If the conform, we label it as a first party. Finding the support party was a bit tricky, since we have to know what type of service is offered by the endpoints. For this, we first scrap the domain information from the search engines. We utilize a set of NLP techniques and a topic model to detect the support party. To evaluate the performance of endpoint categorization, we randomly choose 100 domains from each party types and manually weight the relationship. We have found that our semi-automated approach performed with up to 97% accuracy. At this point, we analyze our data to answer the research questions. Let's focus on the first research question. In this figure, we are showing the distribution of first, support, and the third-party endpoints for different IoT device category. A few insights from this figure is some devices were more exposed to third parties than the others, where smart TVs were most susceptible to the third parties. Among third-party domains, we found that 23% of them were advertiser or tracker. We also found many low-ended devices also exposed to third parties, and our further analysis revealed that among compatible devices from different vendors, that differ in terms of number of endpoints. For example, Samsung camera were seen to connect one support party, whereas Nest camera connects only the first party. Moving to research question 2, we wanted to see if the number of endpoints significantly changed based on the user location, which we try to portray in the figure. It is evident from the figure that the number of contacted endpoints varies across various regions, and we also found that device connects higher number of advertiser or tracker domains when the device is located on the American regions. The other aspect of the research question 2 is to see how frequently data is crossing the geographical borders. In this heat map, we shows the percentage of outgoing data to different regions. From the heat map, it is evident that data is crossing the borders and most data is going to the American regions. We have found, data crossing raises a question of endpoints privacy compliance. To answer this question, we examined the privacy policies for remote endpoints and found that about 59% of remote endpoints provide the privacy policies, among which only 46% of them address that data practice for international and Pacific audience. And many endpoints that communicated by the IoT devices like a web server, which makes it's impossible to check the privacy policies. While our study provided many useful insights, there were some limitations listed at the top, and we are still working on this. In this paper, we presented some recommendations for stakeholders. Firstly, among compatible devices from different vendors, the consumers can choose one of the devices that communicates a fewer number of third parties to safeguard their privacy. Secondly, device manufacturers should highlight what information is collected and where it is sent to make the data sharing practice transparent to users. And the data sharing practice of IoT devices should be investigated by the regulators to make it accessible to all the stakeholders. And thank you all. If you want to access the code and dataset, you can scan the QR code. And if you have any questions, you can email me. And obviously, you can question now. Thank you.
Do we have any questions?
Oh, hi, thank you, very nice work. I'm sure that you have details about this in the paper, but
Yeah.
can you tell us a little bit about how accurate was ChatGPT at labeling the information that you were mentioning?
Actually, we couldn't identify. Actually, we cannot say the accuracy because we said we can infer the device since there were no ground truth. We didn't measure the accuracy. Okay, since we collected the data from organic users, so we don't have the ground truth.
But I thought that some of them you manually annotated and some of them you did with ChatGPT, right? Did you compare your manual annotations versus the ChatGPT?
Yeah. So we found that there were some common devices. Those were both identified by ChatGPT and manually. But interestingly, we have found some devices that two of our researchers manually verified the device identity. They couldn't identify the device, but ChatGPT could, which was impressive. But again, since we don't have the ground truth, we can calculate the accuracy. Yeah.
So one of your categories for devices was surveillance, and I wondered what that meant.
Those are surveillance cameras.
Thank you.
Thank you. Great talk. So, what was interesting to me, so you kind of suggested that a lot of the data went across to North America. Did that was there any correlation with where the products were from? So you talked about smart TVs that, not necessarily from the US.
So we can infer that since many vendors were from North America and their servers are situated in that region, it is possible that there is a correlation. That's why
That's why you got that correlation.
Yeah, right.
We have got the video.
Okay, thank you so much.